This video is going to take us through some changes that were happening in technology and society. We've been looking at America's place kind of on the world stage and how that was changing in the early 1800s, and we've been looking at how much more land we gained during the 1800s, and there were lots of other developments that were going on that were impacting our country as well. This was a time period known as the Industrial Revolution, which is defined as a period of time when using machines became more common than doing things by hand. You see industry, meaning factories or machines, revolution, overthrowing one way in favor of a new way. We get an Industrial Revolution. The Industrial Revolution actually started worldwide in England in the late 1700s, but then it's brought to the U.S. The ideas are brought against British law over here by a man named Samuel Slater. You see a picture of him there. And really, he brought this factory kind of idea to the New England states. So the Northeast is where the Industrial Revolution first gets going in the United States. And what gets set up is something called a factory system, which, factories are common to us, but they were not at the time. Prior to the factory system, most people and most items in America were made by craftsmen from start to finish by one person by hand the whole time. Now we're making the switch to using machines. At first, machines always need power, and at first the power comes from water. So most of these mills, they were called, were set up along rivers or streams, that sort of thing. And the first factories in America are textile mills. Textile means cloth or fabric, so these are places that are processing cotton. And if you take a look at the slide there, you can see how these work, right? The moving water is going to turn that wheel down there by the number 1, and then there's some gears and belts that then cause poles that you can see kind of where the red arrows are, and those poles and gears and belts then also turn, and that provides power, right? So on the floor 3 there, those are spinning machines that are taking cotton fibers and spinning them into yarn or thread, and then up where the number 4 is, we see some people weaving, actually making cloth at looms, okay? Mills did eventually become steam powered and didn't have to be located on a river or stream. We'll be a little more on that in a few slides. But they were kind of a booming thing in the New England area. You can see there it tells you in 1835, Lowell, Massachusetts, which was a New England town that set itself up around these factories, had 22 mills. Within 20 years, it had more than doubled that and was producing 2.25 million yards of cotton cloth per week. Now, working conditions in these mills were tough. Most people worked 12.5-hour days, so that would be from 7 a.m. to 7:30 p.m. if you didn't have any breaks. They did have very few breaks, a little bit of time to eat in the middle of the day. You worked 6 days a week, and typically church was required on Sunday, on your day off. Kids as young as 7 worked in these factories. A lot of the machines, their small hands were valued, and so we had very young children working here. We had women working here, and it was dangerous work with no protections. If your hand got caught in the machine and your finger got cut off and you couldn't do your job anymore, bummer, you were fired. There really wasn't any kind of recourse or protection for you. So, of course, in order for there to be an industrial revolution, there had to be a lot of inventions. Some of the inventions impacted manufacturing. We see a couple of the most important ones here. On the left is the loom. This was a way of using punch cards where either punched was a yes or not punched was a no, and those would you could see them along the top of the picture there. Those would sort of indicate to the thread, should it go through or not go through. This is very basic computing. This is the sort of 0-1 beginning of binary code happening here. On the right, you see one of the first sewing machines. That was in the later, around the time of the Mexican-American War, right, 1840s to 1850, but that's certainly going to speed up the creation of turning cloth into items like shirts or whatever. Also, there's no picture, but another big development that impacted manufacturing was interchangeable parts, being able to use factory machines to make parts of something. So prior to this, if, say, you had a gun that was made by a blacksmith or a gunsmith, and part of it broke, you'd have to go back to the guy who made it and potentially have him start all over making a new one. You couldn't just go out and be like, oh, I need a new such and such piece, right? But once interchangeable parts were made, and so everything was a standard size, you could order just a replacement part. So that was a big change in the way things were made as well. Inventions also did impact agriculture. I want to think farming was left out of this. The cotton gin there on the left, invented in 1794 by Eli Whitney. He was an inventor working on Catherine Green's farm. And I actually should mention, Eli Whitney is the one who applied for the patent for this, because it would have been illegal for women to apply for patents. But there is some scholarship that says this is actually Catherine Green's invention. But prior to this cotton gin, cotton had to be cleaned by hand. When you imagine trying to pick burr-like seeds out of cotton balls, that's what had to be done before the cotton could be used. And on average, a worker could clean about a pound of cotton a day. They could remove seeds from about a pound of cotton per day. The cotton gin, you can see, is just turned by a hand crank, but it has these metal tooth combs, essentially, that sort of comb the cotton, and in that blue area of the picture there is where the seeds are being pulled out and the clean cotton is being sort of brushed on through. This cotton gin allowed 50 pounds of cotton to be cleaned per worker per day. So it's cleaning cotton at 50 times the rate of by hand. Now, this caused cotton to become U.S.'s #1 cash crop, because all of a sudden way more cotton could be cleaned per day. You would think, hey, fewer people are needed to clean the cotton, probably fewer slaves. You would be wrong. Slavery actually skyrockets because of the invention of cotton gin, because plantation owners start to think, if I can clean 50 times as much cotton per day, then I want to be harvesting 50 times as much cotton per day, which means I need to plant 50 times as much cotton per day. So the cotton growing business really took off as a way to become very wealthy, and that happened on the backs of slaves. The invention on the right was used more in the middle area of the United States, what originally was the middle colonies, right? The bread basket. This is the McCormick reaper. You can see there it's a horse-drawn contraption that is cutting down stalks of grain. So this would be for harvesting wheat or things like that. And then the guy coming behind could rake and bundle the wheat or whatever other grain was being picked up there. This allowed people to harvest 5 times faster than by hand. Prior to the McCormick reaper, grain was all cut down by hand with a sickle, a curved knife, a curved blade, essentially. Inventions are also going to impact communication. One of the biggest that happens during this early 1800s time period is the telegraph, invented by Samuel Morse and others, although we know of Samuel Morse because of Morse code. And this was a pretty simple design once they realized about electricity, right? What happened was the contraption that you're looking at there was hooked up to a wire, and the wire, when the button was pushed down, when the lever was pushed down, you can see the metal pin would touch that metal bottom, and it would close the circuit and send an electrical impulse. And then when the person lifted their finger up, it would break the circuit and there would be a pause, right? And so that's what Morse code is based on. Over there, the circles, the dots are a short touch, a short pulse. The dashes are a longer pulse, and you would send messages. You would spell them out one letter at a time. Morse code did also include numbers and punctuation as well. I just don't have those on here. But, I mean, this was a huge change, right? All of a sudden, messages could travel as fast as electricity could travel. Prior to this, messages could only travel as fast as the fastest horse could carry a written letter. This is going to change things like the way wars fought, because a general can now say, hey, President so-and-so, here's what's happening in the field. What do you want me to do? And the president could reply within 30 minutes or so, whereas a letter might have taken weeks or months even, and of course everything on the battlefield would have changed by then. This also is really going to affect the economy. People out west or people far away from wherever an item is are going to be able to start immediately saying, hey, need more whatever, send it my way, placing orders, doing things like that via telegraph. So this is a huge change. It really speeds up society because communication speeds up so much. And then inventions also impact transportation. I told you we'd get back to the steam engine, right? There's pictures on the left there essentially of how the steam engine works. You heat up water, you create steam. You can see in the top picture, it's coming in on the yellowy orange side, and that's going to push that piston, that gray rod inside the red box, to the left, which is going to pull on that green bar that it's attached to, right? And then you're going to use valves to reverse, and you're going to let the steam out on the side where it was just coming in, and in on the other side. That's going to push the piston back. And as you keep switching the valves back and forth, you get the piston moving back and forth, which gets that green bar moving back and forth, which gets the wheel turning. And once you get the wheel turning, you can do all sorts of things with this, right? The first steamboat, which is on the bottom right there in the U.S., was in 1787. The first steam locomotive in the U.S., there's a drawing there on the upper right, was in 1804. And then these are both going to become more and more common throughout the 1800s. So we've got much faster travel of people and stuff now, right? We've got steamboats that can travel against the current fairly easily, that can carry a much bigger load because they have power to move that heavier weight. We've got trains that can pull huge amounts of people or stuff places. Now, there are downsides to this kind of travel as well. These were loud. You can see in the steamboat picture they were polluting, right? They're typically burning coal in order to heat the water to create the steam. And there's also a danger of explosion. If you look back in the picture of how they work, if you start letting steam in and the little valve that's supposed to be letting steam out the other side gets stuck, you're going to have a buildup of pressure in there, and you're going to kaboom, have an explosion. And those were not uncommon either on steam engines or on steamboats. So some downsides, but some real upsides to the invention of the steam engine and transportation as well. Railroads in particular are going to become really, really important, especially you can see from this map in the north. The green are railroads that were in operation in 1850. So it wasn't huge yet, but starting to come on the scene. But within just 10 more years, by 1861, which is going to be the eve of the Civil War, all of the green and red track is laid. Again, much more common in the north. The south had far more rivers that could be navigable, so the steamboat was more popular down there. We're not going to get a transcontinental railroad, a railroad that goes all the way from one side of the country to the other, until 1869, but that's coming as well. The ability to move stuff all the way from the Atlantic Ocean to the Pacific Ocean relatively quickly. One other important thing about about transportation, is canals get dug, the most famous of which is the Erie Canal. That moved, if you look in the map on the upper right, that went all the way across New York from the Hudson River, which is sort of near the right or the east of New York State, over to Lake Erie. So it's connecting the Great Lakes area, which would mean the area where we live, Detroit, right? Throw something on the Detroit River, float it into Lake Erie, get it across Lake Erie. You could get it on this canal and float it to the Hudson River, and then south down the Hudson River out to the ocean. So this is going to be a big change and improvement in the way goods can move from the area of the country that we live in to the Atlantic Ocean. Remember, prior to this, they either had to come across the mountains on carts or had to go south down the Mississippi River out into the ocean, which is a much longer trip. The canal is really just a ditch. You can see on the upper left there. When the governor of New York first started digging this ditch, he proposed it in about 1810 and started digging in 1817. People were like, this is really crazy. I can't believe you're just building a big ditch and filling it with water. But it ended up being a boom for New York's economy. All along this canal, cities sprung up to supply items that people might need as they're traveling on the canal. It also overnight places to stay, restaurants, places to eat. It was just a huge business boom for New York State and ended up being a great idea. You can see in the lower left, the canal system really spread in the Northwest here, not so much in Michigan, but in Ohio, Indiana area, and Pennsylvania area, all connecting the Great Lakes with the great major rivers like the Ohio River and the Mississippi in this area. And it's these canals that are going to build up cities like Toledo and Chicago and Cleveland, right? These are all going to become port cities where the major waterways meet the canals. Transportation roads also improved. There was a national road built 1811 to 1834 that allowed people to move to the west more easily through the mountains. You can see a map of that there. Also, things like turnpikes started to come on the scene, and they worked essentially the way they work today. Of course, it was a wagon approaching, not a car, but the gate would be down, and you would have to pay someone money, and then they would lift the gate up and let you pass. And that money is used to improve roads by doing things like cutting logs and laying them so you're not traveling through thick mud, things like that. So all in all, people are moving farther, faster. Ideas are moving farther and faster. Stuff is moving farther and faster. Because transportation advances allow people to move into land being gained during westward expansion, they start doing that. Urbanization, which is the growth of cities, also starts happening because factories and mills draw people to the cities, especially in the north. Now, these are small cities by today's standards, and they're still not where most people in the U.S. live during this time period, but 6% of the United States population lives in cities in 1800. By 1850, it's going to be 15% of the people. And people are really drawn to key spots along transportation routes because they can make a living there. So if you look at the map in 1790, pretty much everyone lives along the coast here, right? If we look at the map in 1820, we can start to see people spreading westward, and especially look right where I'm drawing my arrow here. You can see the Erie Canal, right? The buildup of people along the Erie Canal. And then when you get to 1850, you've got people all the way out west in California starting to grow, right? But you also can really see the impact of the canals and the spreading train system as population gets more and more dense throughout the Northeast. So technology affects society, also goes on to affect economy, right? In addition to allowing the movement of people, transportation advances allow stuff to move. Orders, like I said, can be taken via telegraph. Items can be sent out via stagecoach and eventually via railroad. So as more items are available more easily in more places, that's going to cause prices to come down. In addition, advances in how things are made, the factory system we were talking about allows for more stuff to be made faster, which is also going to lower prices just because there are more things available. So in general, life becomes a little more affordable for more people because of technology. This also, though, really changes the way that people are making money. In the South, as we said, the technological advances of things like the cotton gin are really causing the cotton industry to boom, which is causing slavery to really go crazy, really be on the rise. That's a huge cash crop and a lot of money coming in that way in the South. Well, as the North is taking that cotton and using it in factory and mills and making items, making cloth, making stuff, transporting that stuff via train to the cities that are up there. So this is that agricultural versus business economy debate that we saw happening with, the Democratic Republicans versus the Federalists. Those parties don't exist anymore. They're going to have fallen apart by this time period, but we're now starting to see that as a major debate between economies of the North and economies of the South. And in turn, that's going to start to create conflict in society and in our country as a whole, which we will look at more in the next video.